Load store architecture of a CPU is a very fundamental concept. The CPU and memory are connected through buses. Now, what is a bus? Buses are a bunch of wires on which information travels between memory and the CPU. There are two pairs of buses connecting the CPU and memory. The first pair is called the instruction bus. In the instruction bus, the first bus is called the instruction address bus, which carries the address of the instruction, and the second bus is called the instruction bus, which carries the instruction from the memory to the CPU. So the CPU sends the address of an instruction via the instruction address bus, and that instruction comes back to the CPU through the instruction bus. Now come our data buses. The first bus is called the data bus. Data from the memory goes to the CPU via the data bus. But here's the interesting part. The data bus is bidirectional, meaning the CPU can either read data from memory or write data to memory. But how does the CPU decide whether to read or write? There's a single control wire, also known as the read-write control line. If this wire is set to 1, the CPU reads data from memory. If it's set to 0, the CPU writes data into memory. Before reading or writing, the CPU must tell memory exactly which location it wants. That's where the data address bus comes in. It works like a house number. The CPU says, "Hey memory, give me the data at address 2048. Only after that does memory know what to send back or where to store new data. Why do we have separate instruction and data buses? Because instructions and data are stored separately and fetched at different times. The CPU constantly needs instructions, so separating them makes the CPU faster. But here's something important. Why do we even need all these buses in the first place? Because the CPU and memory can't directly understand each other. They need a structured way to communicate. Addresses go on one set of wires, data travels on another, and control signals decide what operation to perform. And once the data reaches the CPU, it needs a place to store it temporarily. That's where registers come in, the CPU's tiny, super-fast storage. We'll talk about that next. And don't forget to subscribe for more simplified CS concepts.